So as you saw in what we did in class, we are now going to talk about what if you're dividing. See, we've already done if you had 3 squared times 3 to the 4th, right? We already did if you multiplied the same base. Then what you do is you add your exponents. Well, now we're looking at what if you were dividing. What if you had 3 to the 4th over 3 squared? What would that mean for the math that you're going to do? The long way, which is not the way I want you to do it, the long way is that you write them out. So 3 to the 4th means 3 times 3 times 3 times 3. 3 squared means 3 times 3. And so what's happening, just like any other time you have fractions, when you have the same number on top and bottom, they cancel out to become ones, right? So these guys cancel out. And so it's all you're left with then is these two right here. And so then we get 3 squared. Now that's the long way. I don't necessarily want you to do this the long way. Here's what I want you to do. So let's say I have 4 to the 5th over 4 cubed. What's happening is the 3 4s on the bottom are going to cancel with 3 of the 4s on top, which means we're taking away 3 of these 4s. So we're going to use subtraction. We're going to go 4 to the 5 minus 3, which is 4 squared. And I do, yes, absolutely, this step needs to be shown. I don't want you to write it out like I did in the last problem, but I do need to see the subtraction problem because there are some pretty crazy things that could happen, and I don't want you to get messed up because you're not showing your work. So, you need to write down another rule in your notes. The rule is if you have a to the m, and it's the same base on the bottom, then what you're going to do is you're going to subtract the exponents. And by the way, when you do that, your answer technically is on the top, right? Because if I don't write it underneath a 1, if I don't write anything else besides a to the whatever, then technically that's on top and I could put a 1 on bottom. So your answer then is going to be on top. So this is your rule. Let's a couple examples with this. All right, so if we have 4 to the 5th over 4 to the 4th, then it's as simple as saying 4 to the 5 minus 4, which gives us 4 to the 1. Right? Let's see here. Of course, now sometimes something a little bit crazy can happen. How about this one? 7 to the 5th over 7 to the 6th. Well, I can rewrite that as 7 to the 5 minus 6. And it's really important you write that. Top one minus the bottom one. And then we get 7 to the 5 minus 6 is negative 1. But here's the thing, we don't really want to leave negative exponents. So we need to take that negative exponent and move it all to the bottom. So now it's a positive exponent with a 1 on top. So that would be my answer. So just be careful where you leave your answer. Don't leave any negatives around. Okay. Ooh, this is an interesting one. What if we had 6 cubed times 6 to the 5th over 6 to the 9th? Well, we have a couple things going on here. First, I'm going to go ahead and just do the top math there, which says if you have the same base being multiplied, we go ahead and add the exponents. So we get 6 to the, what's 3 plus 5? 8. And then we still have 6 to the 9th on bottom. So then once again, now I'm dividing the same base numbers. So I got to subtract the exponents, top exponent minus the bottom exponent, which gives us 6 to the negative 1. But we can't leave a negative exponent, so we move the 6 to the bottom. Positive 1 for the exponent, which means I don't have to write it, and a 1 on top. So that could be my answer. Okay, we could also have one like this. So we have 2 over x to the 4th times x squared. Now here's the thing. A lot of people get mixed up on this one because here's what we have. We have a top, we have a bottom, and we have a side. That actually doesn't really work to have a top, bottom, and side. There's only top and there's only bottom. There is no side. So to solve this side problem, which it looks like side, but it's not really, to solve it, let's just do what's naturally. If I have to make something a fraction, I put it over 1. And all of a sudden, it's not really on the side. This isn't really on the side. This is technically on the top with the 2. So I'm going to rewrite this as 2x squared, because they're just being multiplied, over x to the 4th. Right? Because right here, when we had it on the side, it was being multiplied. It's assumed because there's no plus or minus in between. There's a multiplication. So when I join it with the 2 on top, it's still a multiplication. And now we have our exponents here that we can do our subtracting. Hey, by the way, I just want to point out, if you want to, you could do your subtracting on the bottom. So we would have on the bottom, we'd leave the x on the bottom though, but that's important. If you're going to do your subtracting on the bottom, you got to leave your answer on the bottom. And then what that means is I'm going to take the exponent of 4 minus the top exponent. So if I'm doing it on the bottom, then the bottom exponent goes first. By the way, this 2 right here doesn't have an exponent on it. That 2 stays on the top. So now I get 2 over x to the 4 minus 2 is 2. If you didn't do it that way, so let's say we did the top exponent, so we have the top exponent minus the bottom exponent, then that would have been 2 and then x to the negative 2, which means that needs to go to the bottom, so it's a positive 2, and then this 2 in front stays on the top. So either way we get the same answer. So we have a second rule I want you to see, and that second rule says if you have a fraction to an exponent, you are going to distribute that exponent to both the top and bottom of the fraction. So I'm going to get 2 to the 4th and 3 to the 4th. So we get 16 over 81 is our answer. Okay, so your rule that you can write in your notes is a over b. So if you have a fraction to an exponent, then you can place that exponent on both the top and bottom separately, which comes in really handy for us. Okay, so for example, if we had 1/4 to the 3rd power, then technically that's 1 to the 3rd power over 4 to the 3rd power. So 1 cubed is 1, 4 cubed is 64. Or, let's say I have this fraction to the 2nd power. By the way, this negative out in front is not being raised to the 2nd power, so I don't have to distribute that. But I do need to say 4 squared, and I do need to say x squared. They both get them separately. And I know 4 is 4, so 4 squared is 16, but I don't know what x is, so I just have to leave that as x squared. And so that's my answer. Here comes an interesting combination of rules. What if I had 3 halves to the negative 4? So I've got a negative exponent plus I have a fraction. Well, if you remember in previous ones, when we have a negative exponent, that flips our fraction over. So our fraction gets flipped over, and that means our exponent becomes positive. And now we can distribute that 4 to both of them separately. I think this seems familiar. Did we just finish one that was the exact same thing, except it wasn't a negative at first? Okay, so that's pretty much it. Of course, I'll do one more example. I really want to make sure you guys are very careful with your negatives, if the negative's inside the bubble or out of the bubble. So on this one, I have a negative inside the bubble. So what that means is the negative is really a part of the 2. So when I put the 4 on there, I'm really saying negative 2 to the 4th. The negative is included in the exponents. So then that means because 4 is even, my negatives are all going to cancel out and I get a positive 16 over m to the 4th. So be careful with your negatives. Be very thoughtful about that. All right, we're done.